In this optimization problem, we're finding the largest rectangle that can fit inside a right triangle. The first thing we want to do in solving this problem is to read the problem carefully, figure out what information we've been given, and then what we're asked to find. Our problem tells us that we are to find the area of the largest rectangle that can be inscribed in a right triangle with legs of length 3 centimeters and 4 centimeters if two sides of the rectangle lie along the legs. What we want to do now is fill in all 4 of these categories that I've listed here, and notice that I have already drawn our picture just to make things easier. We have a right triangle, and inscribed in our right triangle is a rectangle, and it has legs of length 3 centimeters. So this distance here is 3 centimeters and 4 centimeters. So this distance here is 4 centimeters. Now what we want to do is assign variables. Our variables need to be related to what we want to find. We want to find the area of our rectangle here in red. So we need to make our variables the width and height of our rectangle. So I'm going to let this distance be x and this be y. So let's write that down. X is the width of our rectangle, and then y is the height of our rectangle. Our second category is titled equation. What we need to do for this is we need to find an equation that relates x to y. I think this one is difficult, and a lot of students struggle with this. So let me tell you exactly how we're going to do this. To find the equation that relates x and y, we're going to use similar triangles. If you've studied related rates, you might remember doing this when you had water going into a cone. Now what we're going to do is we're going to compare the sides of our 2 triangles. So let me go ahead and let me highlight our second triangle. This right here is our second triangle, and it has a leg of x, and then this distance right here is 3 minus y. So using similar triangles, we can say that 3 is to 4 as 3 minus y is to x. Let's put that in our pocket for a minute and we'll come back to it. Let's now move on to what we want to maximize or minimize. We want to find the area of the largest rectangle. So that means that we are going to maximize the area of the rectangle. So we need to write down the formula for that area. The formula for the area of our rectangle is x times y. And now we need to get this formula for a just in terms of x. So we're going to go back to our equation and we're going to solve this for y. Let's go ahead and let's cross multiply. This gives us 3x is equal to 12 minus 4y. So we can say that 4y is equal to 12 minus 3x, and y is equal to 12 minus 3x, all divided by 4. Let's now go ahead and substitute that in for our area. A is now x times 12 minus 3x, all divided by 4. What we're going to do in step 3 is to take the derivative of a so that we can find its critical values. And it makes it easier to take the derivative if we write a in the simplest form possible. So I'm going to rewrite this, and I'm going to say that a is equal to 12 over 4, which is 3. So we have 3x minus 3/4 x squared. Then we can take the derivative easily without having to use the product rule. The last category that we have to fill out is the domain. Let's go back here and look at our diagram. The domain is in terms of x, and x can be between this point and this point. So we can say that x is between 0 and 4, and this is a closed interval. So I'm going to put that down because that's going to make a difference to us in a few minutes. For step 3, we want to take the derivative of our area function and find its critical values, and then find the maximum value of a. So let's go ahead and let's rewrite a. A is 3x minus 3/4 x squared. Now we can go ahead and take the derivative. A prime is equal to 3 minus 6/4 times x, and we're going to set that equal to 0. So we have 3 is equal to 6/4 times x. So this means that 12/6 is equal to x. So we can say that x is equal to 2, and we need units with this. So let's go back up. And notice that in our original problem, our links are in terms of centimeters. I guess we did write that down on the diagram. So x is equal to 2 centimeters. Now let's go ahead and let's find y. Here's our equation for y, and that's what we're going to use. So let's say that y is 12 minus 3 times 2, all divided by 4. This is 12 minus 6, which is 6 divided by 4. We can say then that y is equal to 3/2, or 1.5 centimeters. Now what we need to do is find our maximum area. And we have two equations for the area. Let's go back up here and look. We have this equation and this equation. They're the same thing. I think a is equal to xy is going to be a lot easier to use. So let's use that to find what a is. So we'll write down a is x times y. X was 2 centimeters, so this is 2 centimeters. And then y was 3/2 centimeters. So we get that our area is 3 centimeters squared. It may now feel like we're done, but we're not quite done. What we have to do now is justify that this area that we got is a maximum. And to do that, we have to go back to our domain and see if it's open or closed. This domain is closed, so that means that to justify that our area is a maximum, we have to find a at our endpoints and then compare it to the 3 centimeters squared. To find our area at the endpoints, let's go back up and look at our diagram. At this point on our left, x is equal to 0, and then at this point on our right, y is equal to 0. We know that our area is equal to x times y, and we can use that. So a at 0 is going to be 0 because x is 0, and then a at 4 is going to be 0 because y is 0. And then we have a at our critical point, which is 2 centimeters, is equal to 3 centimeters squared. So this is our maximum area. Now we're almost done. Our last step is to reread our problem and clearly state our final answer in a complete sentence. Let's go back up to our problem. We want to find the area of the largest rectangle. So we have to state what the area is. Let's state that the area of the largest rectangle is 3 centimeters squared. And that's our final answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.